Hello, Physics 277 students and anyone else out there in YouTube world that may be watching these videos. This video will be the fourth in our series about how to use the Linux command line interface, aka the Bash shell. In this video, we're going to be talking about the Linux file system so that we can better understand how to make use of certain Linux commands. Let me show you an example of this. I'm logged into the Stony Brook Math Lab systems, in particular the portal machine, that is giving me access to the Linux command line. And currently I'm in my home directory, and let me move down into some of my directories that I have created below that have some files in them. Let me move particularly into my code directory, and underneath my code directory I have a C++ subdirectory and a Fortran subdirectory. Let me move into the C++ subdirectory here. Okay, now I have in here a subdirectory homework1. Let me move into that. And if I do an ls, you can see I've got a file sitting there, hello_world.c++. It's our simple little C++ program that will be the first program we'll write. We won't worry about what that is right now, but we're just going to use this file as an example. Suppose I wanted to copy this file to another directory, let's say over to the Fortran directory. How would I do that? Right? I have to copy between two different directories. And we need a mechanism whereby we can refer to one directory or another when we're not in it. So in order to do that, we have to gain some understanding of the Linux file system. And that's what I'm going to take you through right now. So let me start off. I'll go back to my home directory because we'll make use of that very shortly. Now, what is the file system? I've used that term, but let's explain what it is. The file system controls how files, directories, and other objects within the file system are organized. You can kind of think of it as a library catalog. For example, if you walk into our library here at Stony Brook, we may have 1 million volumes of holdings that are organized. How do you go about finding a particular book? Well, you go to the library catalog, and the library catalog will tell you not only what the call number is, but it will tell you where it's located, what room, what floor, what shelf number perhaps, something like that. Well, the file system is essentially doing the same thing with regard to files and directories and other objects that you can have, such as links, which we're not going to talk about in this course, but which need to be organized. And that's the main purpose of the file system. So let's understand how it works. The file system is going to be organized in a way that is sort of this hierarchical structure that we refer to as a tree. Now, I think this is best explained when we do it graphically. And so I'm going to switch my share here for a minute to show you another app that I have running here. Right. And in this, you should now see a diagram that I've drawn of a file system tree that would be typical of something that you would see on a Linux computer. Now, this is a highly simplified file system. There would certainly be many, many more files and directories than what I have here, but this gives you this sort of schematic idea of how things might be organized. And let me walk you through this organization scheme. At the very top level here, we have what is called the root directory. You might say, well, why is the root at the top here? Shouldn't a tree be growing upwards? And the answer is yes, but for whatever reason, the convention that virtually everybody adopts when they draw a tree diagram here is to draw the base of the tree, what we'll call the root at the top, and to draw the tree growing downwards. So that's what we're going to follow here. So at the very top, we have the topmost directory on a machine here, which we call the root directory. And on Linux and Unix systems, this is always symbolically denoted by a slash. That's what we call the root directory. It has a name of just slash. Now, this root directory, and let me say something about the file system here. This is important to understand. The file system itself may span multiple disks. If you have multiple disks present in your computer, the file system may span these multiple disks, and you won't see the disks as individual entities here in the same way that you would on a Windows machine. What do I mean by that? Well, on a Windows machine, for example, your primary disk would be known as the C disk. It would be denoted by a C colon. All right, and if you added a second disk to the system and you formatted it, it might be known as the D disk, and you would address files and directories on it as D colon something. That's not going to be true on Linux or Unix file systems in general, and this will include OS X operating systems from Apple where it's running BSD under the hood. Everything will look like one big seamless file system, even though these things may reside, your files may reside on different disks. Okay, so we have the root at the top here, and underneath the root we'll have other directories. And what I've drawn here is a typical organization that one would see, although highly simplified. This is a typical organization that one would see on a Linux system. There will be subdirectories under it. And here in this diagram, I've colored the subdirectories as yellow and colored files as orange, just to help graphically illustrate what's going on. So under the root directory /, you may have directories called /etc, which your Linux system will have, and it contains configuration files for the machine. You have a directory called USR. It's usually referred to as user, even though we don't have an E in that. It's just USR, but everybody says user when they refer to that. And we have a home directory typically, and this is where your home directories will reside. And there'll be another directory under there typically called root, and this is the home directory of the root user. Now, this brings up an important point that I should illustrate. This top level directory that's denoted by / is called the root directory. This directory down here named root, R-O-O-T, is the home directory of the root user. It is not the same as the root directory. When people are referring to the root directory, they're referring to this directory at the top /, not the one down here named root, R-O-O-T. Okay, then each of these directories can have subdirectories to it, and I've only drawn a couple instances of that in this diagram. For example, USR basically will typically have a directory under it called bin, which hold binary files, and commands like rm, which is a binary file, or ls will live under that directory. And then for the home directory here, this will typically have the home directories of individual users on it. So let's suppose on this machine we have a user named Jane Doe, whose username is jdoe. She would typically have her own directory underneath home, and within her own directory she might have files such as file1.txt, or another subdirectory named codes, which could hold her version of a file, hello_world.cpp, which is presumably a C++ code that says hello world. We'll learn more about that later when we get to talking about C++. But this is sort of the typical organizational hierarchy that we have here. Now, there's an important point to this, which I want to make here before I go to my next slide, which is that every directory, if you look at just the yellow boxes, every directory has a unique directory above it. That is what we refer to as a parent directory. So for example, this codes directory down here that Jane Doe created has a directory above it called jdoe, which is the parent directory, and we say jdoe is the parent directory of codes. And jdoe has a directory above it called home, and we say home is the parent directory of jdoe. And home has a parent directory, which is /, that is the root directory. You might ask, well, what about the root directory itself? Well, we define the parent directory of the root directory to be the root directory itself. All right. So every yellow box has a unique directory above it. That is not true in the other direction. That is, take for example, the root home directory up here. It's got 4 yellow boxes below it. It's got 4 sort of children, or what we would call subdirectories. By the way, one other bit of terminology, we refer to these things as directories. On Windows systems, people would typically refer to these things as folders. Where did that terminology come from? Well, when Microsoft Windows introduced their desktop, in order to basically make it user-friendly, they put these cute little folders on the desktop that you could click on, and that's where the term folder comes from, right? It postdates the adoption of the idea of the directory, which came from earlier versions of operating systems well before there was a Windows desktop. So on Linux and Unix, in that world, we refer to these things as directories, not folders. We'll use that terminology throughout this course. Now, here's a question. How would we refer to, when we want to access, say, this file, hello_world.cpp, when perhaps we're up here in JDO, how would we access that file? Because it's not directly below JDO like file1.txt. So we need a mechanism to do that. In order to do that, we have to talk about something called paths or path names to files. And to illustrate that, let me go to my next slide here. We'll take the same tree here. Now, what I'm going to point out here is that there is a unique way in which we could address every single file or every single directory on the system. And that's by tracing a path, starting at the root directory, going through each subsequent directory below it here to get down to even the lowest level files, like in this case, the hello world.cpp file down here. And this allows us to define what we call the absolute path, or the absolute path name to the file. That absolute path name to the file consists of a series of directory names that are separated by slashes. And that specifies the position of a file or a directory within a directory tree. So what I've done is I've taken the same directory tree that I had in the previous slide, and I have listed the absolute path name to each of the directories or the files in that system in what we call the full or absolute path. So let me show you, for example. Down here we have hello_world.cpp. What is the absolute path to that file? Well, it would start at the top through slash, move through slash home, move through slash home slash jdo, and slash home slash jdo slash codes. And the absolute path to that file would be slash home slash jdo slash code slash hello_world.cpp. And that is the absolute path to that file. And for any file on the system or any directory on the system, there's an absolute path to it. And it's a unique absolute path. I can say /usr/bin, and that's the absolute path to this bin directory, which is a subdirectory of the user directory, which is a subdirectory of the root directory. Right? So this is straightforward and it makes sense. But there's something that should be pretty obvious here. Suppose Jane Doe has another directory below codes. Let's say it's a directory called C++, and another directory within that called homework1. And then hello world.cpp resides within that directory. The absolute path is going to be even longer. And the absolute path to a file can be at times very, very long when you're reaching way down deep through the file system hierarchy that we have here. So it may not be a very convenient way to deal with things. Let me illustrate this by a practical example. Let me switch my share back so we can go back to actually seeing the shell window that I originally had open here. Okay, so now you should be seeing the shell window that I originally had open. And I'm in my home directory here on the portal machine within the math lab at Stony Brook. And let's see exactly where I am. To do that, there are two ways I could do it. The first way I'll show you, we've seen already, is to issue the command pwd, which is print working directory, although a lot of people say present working directory, but it really means print working directory. And what I got back here was an absolute path to my home directory. And here it is. On this machine, it is /home/campus.stonybrook.edu/dswesty. And you might say, well, what's up with these dots in this name here, campus.stonybrook.edu? That's no problem. There's nothing to say that you can't have dots in the name of a directory on a Linux or Unix file system, so that's perfectly acceptable. What is a little atypical here is that on most Linux or Unix systems, when you have a user account on those systems, the home directory would be /home/whatever your username is. But because of the way that we have the math lab systems configured here, and we have accounts for every student in the entire university essentially available on the system, we've got them mounted in a slightly different fashion. So your home directory here is /home/campus.stonybrook.edu/whatever your Stony Brook University net ID is. As another example, if you were on an Apple system, then typically your home directory would be /user, capital U-S-E-R, / whatever your username is. They do things a little differently, but it really doesn't matter what the home directory name is. You just care where your home directory is. Another way we could have seen this is I could have issued the command echo $home. We'll learn more about what this command means in a later video, but basically the home, capital home is a variable in the shell that basically holds the home directory path within its value as its value, and we can access it that way. Now, let's move into a subdirectory I have here. Let's do an ls command, and I have a number of directories here and some files. All right. Most of my stuff is going to be stored in a file under my SB files as a directory. So I'm going to move there. All right. Now, where am I at? Let's do a pwd command again. You can see I'm in /home/campus.stonybrook.edu/dswesty, my SB files. All right. Do I have things there? Yes, I do. Oh, I meant to type ls. Okay. All right. Let's move into a directory I have called codes. Or code, sorry. And there I have two more subdirectories, C++ and Fortran, right? Let's move into the CPP directory here. And look, I have nothing there right now. Let's look, if I wanted to copy a file there, like this file recap.txt, which was in the code directory, how would I do that? All right. Oops, I didn't mean to say CPP there. That was my bad. Let's do it ls again. There we go. cdcpp. I didn't make that change. There we go. All right, I have a subdirectory there, homework1. Let's look at that. And I have a file there named hello_world.cpp, just like I have in the example that I showed you for Jane Doe's home directory. Now, let's look at the absolute path to where we are currently. I'll issue the command pwd. And look, I have a very long absolute path now. All right, the home directory here is /home/campus.stonybrook.edu/dswesty/mysb/file/code/cpp/homework1. Could I use this to copy the file hello world.cpp to one directory level above me? Absolutely. Let me show you how that would work. I would say cp hello world.cpp, and then I would specify the absolute path to the directory above me. All right, /home/campus/mysb files. Oh, I'm sorry, dswesty, I forgot that. MySB files code / well, that's where we wanted to put it in there. All right, so I would have had to type all that to get the absolute path to refer to the directory there, and then whatever I wanted to name the file there. Let's name it file2.cpp, right? And that works, right? But there's a lot of typing there. That's a very long, unwieldy absolute path to that. So we'd like to have a shorter way to do it. What I would like to have is a command that would allow me to take this file, hello_world.cpp, and move it up one directory level. And to do that, we have to introduce the notion of relative paths. All right, relative paths are a way that we can basically move things around or access parts of the file system without having to specify the whole long absolute path. How can we do that? Well, let me show you. First, let me go back to my home directory. I'll say cd. Now, let's move down, say, 2 directory levels. I'll say mysb files there, and then I'll cd into the code directory again. Right? Turns out there was a better way to do that. Suppose, let's do an ls on the Fortran directory there and see what's in that directory. There's a subdirectory named homework1. Right? Could I access the subdirectory homework1 without actually moving into the Fortran subdirectory? And the answer is yes. And the way I can do that is I can refer to something in a relative to something else the shell recognizes. And one thing that the shell recognizes is it recognizes directories that are in your current working directory. Again, pwd tells us that my current working directory is in my code subdirectory below my SB files. And if I do an ls, I have the Fortran subdirectory below that. All right. Within the Fortran subdirectory, I might have something else. But can I list what's in there? Yes, I can say ls Fortran. And what I'm doing by doing that is I'm using what is called a relative path. I'm looking at the path relative to this current working directory here, or the subdirectory Fortran. And within that, basically, I have another subdirectory, homework1. And so I could say Fortran/homework1 and do an ls, and there I see my file hello_world.fo8, which is my Fortran version of hello world. Okay, could I copy that hello_world.fo8 to this current working directory? Well, perhaps. I could say cp Fortran homework1 and hello world.fo8. So that's a way I could refer to that file, but I need to copy to my current working directory. Well, what I could do is say /home/campus/dswesty my SV files code, and do that, and that works. And if I do an ls, now I have a copy of hello world.fo8 here in that directory. But again, that was unwieldy, right? So I could refer to things relative to a directory within my current working directory. And this is a relative path. It is one form of relative path. Are there other forms of relative paths? Absolutely. And one of the simplest ones is we can refer to the current working directory itself. And let me illustrate how that's true. Let's do an ls-a, all right? And we see a listing of files here. And the reason I did -a is I wanted to show the things that began with dots. And notice there are two things over here. There's a listing of dot and a listing of dot dot. We've seen those before when we used ls-a. What are those things? Well, dot is used as shorthand by the shell to refer to the current working directory. And dot dot refers to the directory above the current working directory. That is the parent directory of the current working directory. And we can use both of those to specify relative paths. Let's see how that works. Let's do the same command we did before, copy, but this time, the second argument, rather than have this thing be a long absolute path, I'm just going to specify dot/hello world.fo8. Right? And that worked perfectly. You can see that the file is there. Let's just actually remove it to show you that and prove that that was what actually occurred. I'll remove hello_world.fo8. All right, do an ls. You see it's not there. Oh, and I mistyped I mistyped world. All right, let's remove it. All right, let's try that command again. Just move back up to my history, and I had a typo there. Let me correct. All right, and I'll execute that command now, and you'll see I managed to copy hello_world.fo8 from 2 directory levels below where I am currently up to my current working directory. All right, now something else I could have done. Let me remove that file again. Oops. Just to prove to you it's gone, there it is. Let's copy it again, but this time when I copy it, I'm just going to say dot, because the second argument to a cp or a move command can just be a directory name. And if you copy a file or move a file to a directory, it just keeps the same file name. So I'm just going to use dot to refer to this current working directory here. When I do that, there's the file, right? Okay, so the dot is a nice way that I can use to specify relative things in a file system that are relative to the current working directory. What if I wanted to move this file hello world.fo8 up 1 directory level? Could I do that? Yes. The dot dot symbol refers to the parent directory of your current working directory. Let me illustrate that. I'll say ls dot dot. What I see here is the listing for the directory above my current working directory. Let me point that out. If I say pwd, I'm in the directory named code right now. When I did ls dot dot, it gave me the directory listing for my SB files, which has all of these things in it. So suppose I wanted to move, let's do an ls. Let's suppose I wanted to move hello_world.fo8 up 1 level. What I could do is I could say mv hello world.fo8 and dot dot. That's the name of the directory that's 1 level above the directory I am now. And if I did that, you'll notice hello world is gone. But if I do an ls of the directory one level above, I'll see there it is right there. It's been moved up one directory level. So we can use this dot and dot dot as a way to refer to the dot referring to the current working directory, and the dot dot referring to the directory one level above. And by the way, when I do the dot dot, it has to be dot dot with no spaces in between. If I try it with a space in between, the shell will treat that as separate arguments and it won't work. Okay, one last way I can refer to things. There's another symbol that the shell uses to refer to a directory that is useful for you, and that is the tilde symbol is used to refer to your home directory, right? If I say, let's look again where I am, pwd, I'm in the code directory. If I say ls tilde, it gives me a listing of my home directory. So I could basically use this to copy or manipulate files relative to my home directory. Let me illustrate. In my home directory, there's a file named file2, which I see there. I could say copy tilde slash file2 to file3, right? And that file3 will be in my current working directory. I'll do an ls now, and there it is. So I managed to copy that way. So we can use these relative paths to move around or to copy to things from one directory to another fairly easily. Now you might be tempted to think that the relative paths are always shorter. That's absolutely not true. Let me show you an example. Here in this in the diagram that I showed, I should say, I had a file named hosts in /etc. All right, let's do a cat on that file. So I'll say cat /etc/hosts. This usually exists on most Linux systems. All right, and that's a file that contains IP addresses for various hosts. So I do that, and I get a listing of that file. All right, so all I did was type /et/host. That was the relative path that or the absolute path that I used to get to that file. Let's compare that to what I would have to do for a relative path. For a relative path, I would basically have to move up from here, 1 level, 2 levels, 3 levels, 4 levels, and then go down a level into hosts, into etc to actually access that file. So let me show you. If I say cat, up 1 level, up 2 levels, up 3 levels, up 4 levels, and then into the etc directory and hosts, right? Oops, I missed the directory level there. So add one more, /dot dot, right? I get the same listing, but compare this path right here to the path that I had before, which was just /etc/hosts. So sometimes the absolute path will be shorter depending on where you are located in the file system relative to where you want to access. So that's an important point to understand. So I'll stop for now. We'll continue making use of this in later episodes of this. I'll post a link to the next episode. It'll be in the upper right-hand corner of this. So if you have any questions, please see me during office hours, or you can post comments, and I'm happy to try to address them. Otherwise, I'll see you here next time.